Today is about order of operations. Order of operations shows up in all of algebra. So really important day. I'm sure a lot of us have worked with some order of operations stuff before. So a lot of it will be just reminders. But let's start with just some number things. So the first, I have 2 to the 4th. 2 to the 4th means what? Sebastian, you raising your hand. What does that mean? You got it. 2 times 2, 4 times. Or 2 times itself 4 times. Now, I'm going to actually pause the video. So if I'm doing this multiplication, I would first do 2 times 2 is 4. Then I could take this 4 and multiply it by the next 2. I could also do this 2 times 2 and call it 4, and then multiply those two numbers to get 16. Okay, so 2 to the 4th is 16. If you're somebody that's like, yeah, I don't know if it was 8 or 16, I'm going to always encourage you to do stuff on paper. Okay, write it out just like I did if you can't do it in your head. All right, this next one. Anybody have an idea what these bars are, these lines? Yeah, Angel.
I don't know exactly what it is, but I know that whatever number is beside them will always be a positive number. I think it's like true value or something.
You're close. Not true value. Somebody else have a different idea? How about absolute value? And we're going to make a note of this. Absolute value. Now, by definition, absolute value is a number's distance from 0. So a number's distance from 0. And because it's a distance, there aren't many situations where you would ever describe a distance as being negative, right? If I'm describing, let's say, how far I am from just my chair here, and I'm 3 feet away right now, if I walked in a circle and was always 3 feet away, even when I go to the other side, you're not going to tell me that I'm negative 3 feet away, right? I still would just simply be 3 feet away, okay, no matter where I'm standing within that given circle. So the whole point of that is to show us that distances stay positive. So when we're taking the absolute value of a number, we're going to always just make it positive. So make the number positive. So the absolute value of negative 10, its distance from 0 is 10 units. So we would just say that that is 10. If I was taking the absolute value of 10, that is also 10 units from 0. So this would, again, be 10. We're not making a negative. It just always turns to positive. If it's already positive, it stays that way. This little check mark looking symbol, what does that mean? What? Somebody raise their hand. Yeah, Kaylin. Okay, Julian. Square root. What does square root mean? Good, right? What number times itself is 16? It's the opposite of exponents. Okay, opposite is squaring something. So with this, we're thinking what number times itself is 16. Julian was on it. 4, right? 4 times 4 is 16. But is there another number that times itself gives us a positive 16? What about that? Does negative 4 times negative 4 equal 16? It sure does. So when we're taking square roots, technically there is a positive and negative number that makes that true, okay, that it equals. A lot of times we'll only take the positive number here, but I do want us to have it on our radar that if we're thinking about one number times itself is 16, that is positive 4 and negative 4, because the negative times a negative gives us that positive. All right, and the last multiplication here, negative 2 times negative 2, that's 4. 4 times negative 2 is negative 8. Okay, multiply two things together, and then the product of that times the third number. Okay, so we're going to go ahead and talk about the order in which we do all of these operations. A lot of us are familiar with the term PEMDAS. I actually use just a different form of that. It is the exact same order, but I call it GEMS. So GEMS. Okay, so GEMS, meaning the G stands for grouping symbols. So if we have grouping symbols, parentheses, or brackets, or absolute value brackets, or potentially even division, this needs to happen first. Okay, so that is the very first thing that we're going to do. And I am going to write out our numbered steps as we go through the actual problems here. After we deal with anything that has grouping symbols, we're then going to transition to our exponents. Okay, so that's the E in GEMS. So grouping symbols is the G, E is the exponents, followed by the M, actually stands for both multiplication and division. These are equivalent, at least in terms of the order in which we need to do them. Yes, with PEMDAS, multiplication comes before division, but it actually doesn't matter the order in which we complete these. So we're just simply going to work left to right when we have multiplication and division. And then the fourth set of operations, the S, it stands for subtraction. It just makes our acronym flow a little bit better, but that is addition and subtraction. So these are again equivalent, and we're going to work left to right to simplify. So when we do these order of operation problems, we're only going to do one thing at a time. Okay, and I really want to emphasize that. Some of you might be really good at this and say, Miss Young, I don't need to show work. Okay, but that's something we have to work on. Showing work limits opportunities to make mistakes. It also allows us, if we don't get it right, to go back and fix our work. Okay, so we're going to show basically every single step, and we're only going to do one thing at a time. So let's do a few problems together. Then I'm going to get a lot of you, and we're going to be coming up to the board and working through some other problems in different ways. All right, so here's how we're going to go through these. We're going to list our steps. So step 1, that's our G for grouping symbols. So we're going to deal with any grouping symbols first. When I'm dealing with the grouping symbols, everything else is going to stay the same. So I still have this 6 minus, but then inside my grouping symbols, we need to go through those order of operations again. It's not that clear, but this is division. So inside of our grouping symbols, there aren't any. Exponents, there aren't any. But now I'm seeing some division. That needs to happen first. So 6 minus 4 divided by 4. 4 divided by 4 is 1. And again, I'm getting that from 4 divided by 4. We still have our grouping symbols, so this is still our first step. Or our first operation. 6 minus 1 is 5. As soon as we have simplified, meaning we've done all the operations inside the grouping symbol, you can drop the parentheses if you want to. Okay, we don't need those parentheses anymore. If you keep them, it is all the same. And the next step would be exponents. There aren't any. So we're still going to write our second operation, but we just put an X through it, telling us that we don't need to do any exponents. 3, multiplication or division. We don't have any. So we're left with our last set of operations being addition or subtraction, where 6 minus 5 is 1. All right. On to number 2. Operation 1, grouping symbols. Again, I don't see any. Operation 2, we have exponents. Okay, 3 cubed. Maybe we need to do, I call this side math, where I take 3 cubed to the side and I try to figure out what that is on paper, okay, not in my head. Because I know that I can do 3 times 3 to get 9, 9 times 3 to get 27. So 3 cubed is 27. Then plus 6 minus 3. After exponents, we have multiplication or division. None. Step 4, addition or subtraction. We're going to go left to right, doing one operation at a time. 27 plus 6 is 33. Then we still have to minus 3, which gives us 30. Okay, so again, notice how I'm only doing one operation. I'm not getting ahead of myself and trying to do more than one thing and writing out every single step. All right, last one. Number 1, grouping symbols. We have some. That's 1 plus 1. That is 2. I have not done the division yet. That's a division symbol. I know it kind of looks like a plus. It's hard to tell the difference there. But that's division. So far, I've just done my grouping symbols with the 1 plus 1. Why what? You're good. You're good. All right. Step 2, exponents. We don't have any. So step 3, we're on to our division. Again, with division and multiplication, we're going to go left to right. So 4 divided by 2 is 2. 2 times 5 is 10. Okay. Questions here? Go and flip this page over once you've got everything written down. And we've got 3 sets of 3 to work through for the last little bit of these notes. I'm going to have you all do 4, 5, and 6 on your own. Even better would be in your groups where you all agree on an answer and do the same thing. Don't get ahead of yourselves because we're going to do something different for 7, 8, 9, and 10, 11, 12. Question?
Is it okay for the division if you are doing steps like above and below at the same time? So like if I, for example, on the first one, like 4 plus 4 and 2 times 3 and so on.
Okay. Let's see how we did here. So number 4 is a little tricky. Because it looks like a big fraction, and it is. Remember that all fractions are just simply division problems. Now, one thing that helps with this, when we have this big fraction, which is called a rational expression, there are basically invisible parentheses around the numerator and the denominator. So I add those in because that is the first thing we need to take care of, are the grouping symbols in the numerator and the denominator. Those need to get completely simplified before we actually carry out the division. So I add those in, and then I start my order of operations. They start all over. So in the numerator, I have to multiply first. 4 times 2 is 8. 8 plus 4 is 12. In the denominator, 2 times 3 is 6. Now that the numerator and denominator are simplified, we can go ahead and carry out the division, where 12 divided by 6 is 2. Okay, that's a hard one. Okay, because without us knowing to do the entire numerator or top of fraction and the entire denominator or bottom of fraction first, it gets a little tricky. All right then. Number 5. Again, be careful. A lot of math is attention to detail. So we start with an open parenthesis. I see another open parenthesis, but then I see 2 that are closed. So this closing of that first parenthesis happening after this 1 is going to change the order in which we have to go through these. So I'm like, okay, inside this big group, which I'll go ahead and draw that in as red, I need to do the 2 minus 1 first. That gives me 1. Then I can do the 3 minus 1, which is 2. That 2 is going to get multiplied by the other set of parentheses here, the 1 plus 2, which is 3, where 2 times 3 is 6. There weren't any exponents, so I crossed off my second set of operations, ending with 6. All right, number 6. This one's a little more straightforward. 6 minus 4, so our grouping symbol, that's 2. 2 cubed, 2 times 2 is 4, times 2 again gives us 8. Now we can go ahead. There is not any multiplication or division, so we'll skip that and move on to our addition or subtraction, which is 12 minus 3, giving us 9. So we end with 9 there. Okay, we're going to get lots of practice with these, and how we're going to go about doing 7, 8, and 9, and 10, 11, 12 is a little bit different. I'm going to pause the video recording. All right, for those of you watching on the video, I'm going to ask that you pause the video. I'm going to go ahead and show all my work for 7, 8, and 9, and you can unpause the video to check your work once I'm all done here. So we're going to hit pause, work through 7, 8, and 9. You'll see your answers once you unpause the video. All right, and for those of you that are watching the video, you can go ahead and check your answers here, getting 17, 4, and 10. All right, for those of you watching the video, I just want to recap. I made a mistake. 12 divided by 4 is 3, not 4. So this answer should be 9. Make sure you do catch that. But we're going to do the same thing for 10, 11, and 12 that I had you do before, which is pause the video, do your best to work through the problems, make sure you're showing your work. And then after you unpause, you can go and check and see everything that I did here. Just go and hit pause right now and do your very best to work through 10, 11, and 12. All right, for those of you watching the video, again, you can go and check your work here, ending with 5, 3, and 2. I don't think I made any mistakes this time around. Might have happened. If I did, hopefully you catch it. And that concludes this lesson for today. You have a homework assignment that follows. As you work on your homework, again, make sure you're showing all your work and writing out all the steps.